Alright, in this video we are going to try to plot a Cartesian plane using the Linux terminal. Should work for any terminal. So I have my text editor Atom open here in my desktop, and I'm going to create a new file. We're going to call this plot.py. Okay, so one of the first things we want to do here is add our hashbang. Sorry, we're going to run this with Python 3, and we also need to change the mode and make this executable. Plot.py, and then we can run it like a script. Format string here. Alright, and test this and see if it's working. I haven't done anything too fancy yet, so we're running this program plot. Okay, so the idea here is we need a grid system. A Cartesian plane is the plane for graphing we've seen in algebra. Most commonly, it's an x and y axis crossed in the middle. The point 0, 0 is known as the origin. Now this gets a little complicated because the way the terminal prints things out is not the same way that we want to organize our number system, right? So if we think about when we print something out to the terminal, I can print a character A, and the print command by default uses a new line character. So in Python, by default, it automatically prints a new line character after everything you print to the terminal. But if I use my ending character, if I change that, so this is a keyword argument, I'm setting it equal to the empty string, and normally this is the new line character, right? Now it'll just print out an A, right? And this % means that's the end of the file was reached, or the end of the program was reached. So there was no new line character. Now I can print out a B, right? An A, B, and I can keep going like this. But notice the way the print command is working. It is starting on the first line and going left to right, right? One character at a time. I cannot write on the second row until I've completed writing the first row. So here I can print, and that's going to create a new line, and I can copy and paste this. So now we've completed this first row, we have a new line, and then this will be D, E, F. Alright, and we'll go ahead and add another new line character there. Alright, the reason this is adding a new line is because effectively I'm not printing anything, but I've got the ending character as a new line character. So Python is printing out the new line at the end, even though I'm not printing anything. Alright, so we can run this, and we see we print one character at a time from left to right on that first line, and then we move down a line. So the way that this the print function works is very important to how we are going to be printing out our graph, which means that we can only print out the entire top row of characters first. Then we go to the second row from left to right and print out. Okay, so that is entirely dependent on the way print works with the terminal. All right, so that's going to be important. That's how we print things out. All right, so we can start by printing out a box or a basic grid. Right, so if we wanted to do this, we're going to need, a couple of for loops, and we need to know how many columns and how many rows do we want. So let's just start out with something, simple, 8 columns and let's see, rows equals. Let's make this 16 and 8. Okay, and so for some y value in rows, and for some x value in, sorry, not in rows, this is going to be range rows. And so for some x value in range columns, right? So range produces an iterable. It's kind of like a list. You can iterate through the items one at a time, starting at the beginning. And this iterable item it is kind of like a list that starts at 0 and ends at 1 minus rows. So rows is 8, so this will be a list going from 0 to 7 inclusive. This will be, and the y is meant to represent the vertical component of our grid, right? So when y equals 0 to start with, that's going to be this first line. Y equals 1 will be the second line. Y equals 2 will be the third line. Okay? Actually, 0, 1, 2, and then 3, right? So then x is going to be the x position, right? So x equals 0 is going to be the first character, x equals 1, the second character, x equals 3, the third character. All right, so that's what the purpose of this double nested for loop is, right? So now we have an x and a y value, right? So we can kind of print out a border to see, you know, what our grid looks like. And in order to do that, we might need to say for the top lines, you know, if y is equal to 0, we're going to print a hyphen character and have an end like that, right? And then if y is equal to rows minus 1, we'll have the same ending character, right? Now this is going to be an else if, right? The idea here is we're going, for every single coordinate pair of x and y, we're going to print out one single character. All right, so if our y value is 0, that's going to be this first row, and we're going to print out a hyphen for each one of those characters. If y is the last item, we're going to print out a hyphen as well. All right, and then otherwise, we're just going to print out empty space. Okay. Now this is for x in range columns. So this inner for loop is filling up one row of data, right? So the x value here is 0, starts out at 0, which is going to be the first character. Then the x value is 1, which will be the second character, third, fourth. So it's filling up one entire row of characters. And notice each one of these print statements does not have a new line character that it's printing, right? We've changed that ending character to be blank, so it's going to print one character after the other on the same row, right? Once we have completed the entire row of data, which is one iteration of the outer loop, which is a full iteration of this entire for loop, that's one row. All of the x values have been filled out. Then we add our new line character. All right, so this is going to run, fill out, this for loop is going to fill out one row, each of the x values from 0 to columns minus 1, and print a character. If the y value happens to be 0, it's going to print a hyphen. Otherwise, or if it's the end, right, it'll print the hyphen. Otherwise, it's going to be a blank space. Okay, so we see we kind of have the top of our grid, and then all through here, everything on this line, the y value we have is y equals 0. Then here, everything on this line is y equals 1, right? So y doesn't equal 0, so it's not going to print out that. Y doesn't equal rows minus 1. Rows minus 1 is 7, right? So y is 1 here. So that means the spaces are going to be executed or printed out, right? And then after we print out an entire row, then we print out the new line. And then the for loop on the y side, right? Y is our vertical direction. We increase y, and it's one row at a time. And the reason we have to do it this way is because of the way the print function works with respect to the terminal. All right. So let's add a border on each side, left and right. We can do that with elif x equals 0, and we can make a pipe for that. Right? And instead of having two separate conditions here, right, we can just say if x equals 0 or x is equal to columns minus 1. Right? We can do the same thing up here. Y equals rows minus 1. Okay, so if either one of these conditions is true, that means we're on the edge. We print out a horizontal bar. If either one of these conditions is true, that means we're on an edge and print out a vertical bar. Okay, so that's the box. Now the problem with this style is we have this concept of an x and y coordinate, right? Which is fine. We have an x comma y. Now if you think about the way this works, x starts out at 0, y starts out at 0. The very next iteration of this loop, x is 1 and y is 0. X is 2, y is 0, right? So we're basically printing out that character, then the second character there, then the third character, one character at a time until we get to the end all the way through that inner for loop. That for loop completes, and then we print our new line. And so we go back down, and now y has incremented. So now our y value here is 1. Okay, so this is a different coordinate system than what we want. We want, for our purposes, we want a coordinate system where x and y start out in the middle here. Right? So this very first character here would be, you know, however much this distance is. Negative, you know, if we're starting out, we have 16 columns, right? We'd have to pick something in the middle, and this might be like -7 x. And then the y value would be positive. So it might be +4. Okay, so we have to find some way to translate this sort of grid system into a grid system that's like more like a Cartesian plane. All right. So what we can do there is change the way our range function creates that iterable. All right. So to make this a little bit easier, let's set up our columns and rows, and we're going to make the axes in the middle, and then there's going to be equal number of units to the left and equal to the right, or an equal up and equal down. Okay, so that means we might have 15, right? Or let's do 17 and 17. Okay, what this does is if we have our axes in the middle, right, that's going to account for one of our units, so we'd be down to 16, and we'd put 8 on either side of that axis. All right, so that's how we're going to do this. We have rows and columns. Now, this outer loop, as we said, we want that to start for the y value. That's going to start with a high y value, right? In this situation, if we're printing out 17 things and in the middle the y value is 0, right? That means there's going to be 8 values above it, right? So this is really the starting point here for our y value is going to be 8, and our ending point is going to be -8. Right? And then we're going to go down by -1. Right? And then for columns, it's the same idea, except our starting point is in the negative, right? The starting point over here is supposed to be -8, and then when we get to the middle, it's going to be 0, and then when we get to the right, it'll be +8. So we're going to go -8, 8, and go up by 1. All right? So now that we've changed the way that our x and y coordinates work, right, these won't make sense anymore. The else statement will. If anything else happens, we're going to print out a space. So if we don't have any of these conditions met, but we need to rework these. So instead, since our Cartesian plane doesn't have boundary boxes, it just has axes, what we can do is we can say if x equals 0, now this is the x value, right? So we're going to print a pipe, and then elif y equals 0, right? That would be the y-axis, right? Or actually, that would be the x-axis when y equals 0. Then we're going to print out a hyphen. Okay, so now we have this kind of idea of a coordinate system, right? -8, -8. Let's see, this would be, I'm sorry, -8, +8. So -8 x value, +8 y value. And as you go this way, this would be -7, 8, -6, 8, all the way until here we get an x value of 0, 8. That's that character, right? This is 0, 0. This is -8, 0. And then this would be 8, 0. And then this would be 0, -8. Right? The coordinate pairs that we're used to on a Cartesian plane. So that's what we've done here. One thing we might want to do is, since we're using static values here, we can't ever, change our height and width of our graph. Okay, so we might want to put these in terms of our values here, of our value columns and rows. Right. So this is rows, basically. Rows divided by 2, right? So we could say rows divided by 2. This is negative rows divided by 2. All right, now this would give us a decimal value. Right, the range function takes integers, so we could do integer division, which is the double equal sign. If I Python 3 here, we have 17 divided by 2, right? That's 8.5. But if I say 17 integer divide, which is 2 slashes, right? That rounds it down. It takes the integer value. Okay. So this would go to 8 to -8. And then this one would be columns. And we want that one to start negative. And this one to be positive. Oops, 2. There we go. All right, and then see that's fine. And now we can make this bigger if we want, or smaller. We could make this 8 and 8. Or let's do 9. So we have the middle axis. All right. Now shrink it down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is columns is 9 divided by 2, 4.5. That should be 4. And that should be 4. So that should be -4 and 4. This looks like it's off by 1. So why is it off by 1? Print out columns. We're going to print out columns integer divided by 2, and then columns divided by 2. Print that out and see at 9, -5, 4. All right. So when you do the negative version, it always rounds down. So this negative value needs to be in parentheses. There we go. So that means whenever I use these negative values, that needs to be in parentheses because the division doesn't occur first. The negative value takes precedence. All right, run that. That's closer. 1, 2, 3, 4. 1, 2, 3, 4. Oh, and our ending point, right? The range function never ends on that last value, right? So we actually want it to go all the way up to positive 4. So we have to add 1. And in this case, the y value is going down, so we would subtract 1. And here, we have to add 1. All right, so now that's even Stevens. We've got 4 on this side, 4 on that side. We've got 4 and 4. And now I can change the value back to 19. And now you have an even grid. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? All right. We'll see if the odd values or the even values work. One side should be longer than the other. Oh, actually, because the way we did it, it won't be. So good. This takes care of the situation where we say columns 18, rows 18. It makes sure that there is an odd number. That way we can have that middle character be our axis. All right, and there's always going to be an equal number on either side of each axis. So that's good. So we'll put this back at, say, 21 and 21. And now we have a grid. Right? That's a little too big for our view. 17 was probably good. Maybe 15. All right, so there we can see our whole grid. That's good. We don't need this print statement anymore. All right, we can add an additional if statement up here. So I just copied and pasted that. This is going to be an elif, right? This entire if, elif, else statement must be one statement in that we want to make sure that one character is always printed. We can't have more than one character printed each time through this loop, and we can't have less. It has to be precisely one character each time we go through this loop, because these two loops represent, this represents printing a row, and this represents a column in that row. Okay, so we're filling out the columns in a particular row each time through this loop. All right. So here, if we wanted to add something to the origin, we might say, let's see, we have a tuple. That's a current point that we're printing out. Right. And that's going to be our x value, and then our y value. And we can say if the current point is equal to 0, 0, that's our origin. And so we'll change the marker of our origin to a plus sign. So that's going to be this right here. Okay, so we see that the origin has changed to the plus sign. All right, now if I wanted to plot some points, let's say I had some points I needed to plot. And I have them in the form of tuples, and this could be like -3, 5. It could be 6, 4. Be -7, see, do we have, yeah, we have 7, negative 7, negative 5, and we'll do, oh, let's see, we need a 3, negative 4. Okay, so I have these points in a list. So each one of these items I want to check for, and I want to plot them on my graph. All right, so that's relatively easy. All I have to do is in this if statement, and this needs to be, I need to decide which one I want to take priority. Okay, so for example, if you look at this point, 0, 0, we see that all of these conditions would be true, right? The current point does equal 0, 0. That just happens to be the first one, so it takes priority. It has to be at the top. If it's not at the top, then one of these other ones will be true, because x is 0 and y is 0. Right? I can just move this down and show you. If we move this down here, and remember we have to make sure it's an elif, if elif, else. Okay, so this one is going to be true, and so now our origin is no longer going to, we're never ever going to reach this condition, because x is always going to be true if our current point is 0, 0. So this is kind of useless code here. If I run this, we see that the first item in our if statement takes precedence. This is the first case to become true, and it ignores the rest. Right? So as we order these things, it's important that we order them in the priority we want them to be displayed. Okay, so if I have a plot point, I probably want that plot point, oops, a little error there, I want that plot point to print over the origin. Okay, because otherwise I wouldn't know that there's a point there. Okay, so I'm going to make this an elif statement and have an if statement here, if, and basically I'm going to check to see if my current point is in my list of points. And if it is, then I'm going to print a big X. Okay, so now we see that we're plotting points here. Right? We've got x values, so let's double check. We've got negative 3, 5, so 1, 2, 3, and then up 5, right? We've got 6, 4, 1, 2, 3, 4, 5, 6, and then up 4. Right? We've got negative 7, negative 5. It's negative 7 all the way to the edge, and then negative 5. And then we've got 3 and negative 4. Okay, so the plotting points appears to be working. Now what we could do to make this more interesting is test out. We could randomly generate some plot points. Or we could get them from the terminal. So let's start with random data first. Random. And then how many points do we want to generate? Number of points, say 7 for I in range number of points. It's going to loop 7 times. Points is an empty list. We're going to add points to here. So we have a point is going to equal some tuple, and that tuple is going to call random dot rand int, and we're going to go from basically rows divided by 2. I want the negative version of that. So, right, we want an x and a y value, right? Let's do this. We have x equals, and then we're going to have a y equals under here. Okay, so what does x equal? Random dot random integer. And rand int is not like range. Rand int is inclusive. It includes the beginning and the end value. So our beginning value is negative, and we're talking about columns, right? So this is the x value, so it's the number of columns divided by 2, and then it goes into columns integer divide 2, and then our y value is the same idea, random rand int, and that's going to go from negative rows integer divide by 2 to rows integer divide by 2. Then you have a point x comma y, and then points the append point. Alright, so that should generate 7 random points. Now it might generate a duplicate periodically. So here, in this case, we see there's only 6. That's because one of them is probably a duplicate. Right? So that's one way you can create a Cartesian plane and plot points using the terminal. And it's important, again, one more time, we have this nested loop here. This y part has to come first, and that's only because of the way the print function works. The way things are printed to the terminal is one row at a time, top to bottom, and then one column at a time on each row from left to right. So that is why the y loop must come first, because of the way the print function works.